receiving my final year in information technology. I'm very interested in the area of aeronautic system, renewable resource, and embedded technology, which motivate me to work on innovation project that solve a real world problem. Today, I'm here to present my project, design and development of the autonomous solar efficient glider for the sustainable aerial application. In this project, we designed the development a solar powered smart aeroplane which is based on fixed wings glider system. Unlike drone, this aeroplane is used to aerodynamic lift to fly efficient and uses solar energy as its main power source. The main goal of our project is creating a long duration, energy efficient and eco-friendly aerial system for the real world application. The main idea behind this project is very simple. Instead of depending only a battery, we use sunlight as a continuous energy source, which make the system more efficient and sustainable. Our problem statement is before developing the system, we analyzed the existing problem in the drone technology. Most drones today suffer from the limited battery life. It's flying only for the 22 to 40 minutes. This become a major issues in the applications like a disaster management and monitoring system, border surveillance, and agriculture, where the long duration operation is required. Another problem is the high operating cost because battery needs to charge a frequency and replace over the time. Also, the traditional drone are not environmentally friendly since they depends on non-renewable energy source. So there is a strong need for the system that is long lasting, cost efficient, and eco friendly. This is how our project idea was developed. The proposed solution of what we built. To solve this problem, we designed the solar efficient autonomous glider. This system uses solar panels to generate power, store energy in the battery, flies autonomously using the intelligent control system, carrying the sensors and camera from the real-time monitoring. It's a main design for the applications like a disaster management, border security, and environmental monitoring. So our solution is combines renewable energy, autonomous plus aerial technology. Working principle, how the project is works. Now let's understand how the system work step by step. When the glider is exposed to the sunlight, the solar panel converting the solar energy into electrical energy. This energy is either directly used by the system or the storage in the battery. The battery then supply the power to the components such as flight control, sensors, GPS, and communication module. Meanwhile, the sensors continuously collect a real-time data like speed, attitude, and direction. This data is sending to the flight controller, which processes and make a decision. Use GPS and a programmed algorithm, the glider can follow the specific path, maintain the sustainability, adjust to environmental changes. All these processes happen automatically when makes the system fully autonomous. The hardware components detail explanation. How like to explain about the hardware components which are used in our project. The hardware components from the backbone of the system, the solar panels are mounted on the wings of act as a main energy source. They continuously generate the power during the flight. The lithium polymer battery we are using, it's not a battery, it's a battery store this energy and supplying it when the sunlight is not available. It ensures the uninterrupted operation. The flight controller, such as a Arduino, act as a brain of the system. It receives the data from the sensors and control the movement of the glider. The GPS module providing the location data, helping the flight navigation accurately. In the additional communication module like a 4G are used to send the data to the ground station. So we are using this LTE network. It's have a frequency 1.5 to 2.5 kilometer from the ground station to the flight. So it help to transfer the data which collected from the ground level activities, like collecting the images, videos, and sends to the control room using the communication module of LTE network. So the all these components are the interconnect and works together as a complete system. So in this manner, we are using the sensors each of the system. The sensors plays a very important role in make the system intelligence. The gyroscopic measure orientation and helps maintains balance during the flight. The accelerometer detect motions and change in the speed. The altimeter measures the altitude, ensure the drone maintenance proper height. The aerospace sensor calculate how fast the drone is moved. All the sensors together from this IUM internal measure unit, which is continuously send the data to flight control. Based on this data, the system can make a real-time decision and maintain the stable flight even in the wind. Heat and the power management in the long duration system like our heat and power management are the very important. Solar panel generates some heat while observing the sunlight. Similarly, the battery and electronic components also provide produce heat during this operation. To maintain this, our glider used to natural aeroflight airflow during the flight as to cooling the system. Since the flight is continuously moving in the air, heat is automatically dispute. The battery management system is also used to control charging and prevent the overheat. This ensures that all components operation safely and efficiently for the long duration. Software and the control system part of the project is equally important. We using the programming language like a Python and C++ along with the Adreno Pilot software for the autonomous flight control. The system work the continuous loop, sensor collection, data processing, decision are the made, actions are executed. These loops always the drone to operate in independently independently without a human intervention. Here, how the solar energy, observing the solar energy in the solar panel, it's converting into renewable energy. So the results and performance, our project is achieving the very good results. The gliders was obs- able to fly up to 8 hours continuously under the sunlight. We reducing the external charges dependency by the 60 percentage. The navigation was very stable with less than 2 meter devotion. We also achieving the real-time data transmission with in a 5 kilometer range. These results prove that our system is efficient and reliability. Now I'm going to discuss about the application and importance. This project has many real world application. It's can be reduced, can be used in disaster management to the locate victim quickly. In the border security help in the secure and safe surveillance. In agriculture it's monitoring the crop health. In the environmental studies it's track the forest and wildlife. It creating the positive impact socially, economically, and environmentally. So in this project, we have a main benefits to improved safety in this border area, faster rescue response from this rescue team, and save the many of the life in this emergency situation economy. So it's having reducing the maintenance of the cost. It's during comparing to the helicopter or the drone. It's have a low maintenance during the solar energy. It doesn't need battery charges cost. So environmental 100% it's a renewable energy and it's eco-friendly to all others and reducing the carbon emission. It don't pollute the surface. So we are implementing the technologies to promote innovation in the UAV. It's nothing but unmanned vehicle and clean energy. Our main strategy is strengthen the nation, secure and the disaster management capability. I would like to conclude our project is successful demonstrated that solar powered autonomous glider can achieving the long duration flight. They reducing the dependency of the battery. They are eco-friendly and cost efficient. This project is response a step towards to the future for the smart and sustainable UAV system. By integrating the solar energy harvesting with autonomous navigation, the system ensures the existing flight time duration without the needs of frequency, recharge the manual control. Without the man help, it will all the works will be done automatically. So throughout these projects, we have going to having a key challenges like a weight optimization, efficient power management, and sustainable flight control were addressed through the design, iteration, and stimulation testing. Overall, the demonstration the valuable of solar powered autonomous platform for the environmental monitoring, surveillance, and the smart aerial application. Thank you for listening to our project explanation. I hope you understand the concept clearly.